This is section 1.5, part 2. Be sure you've already watched and done the homework from section 1.5, part 1 before this video. We're going to go back and review our midpoint and our bisectors. So here's our picture. We have a large segment that has endpoints A and B, and point M is the middle. Now they do tell us M is the midpoint. Be sure you are told that and that you never assume that M is a midpoint. So the length of AM, because if we leave this symbol off, it is talking about the length or the distance from A to M. So from here to here is 6. And it wants the length of MB. Since M is the midpoint, the two halves are equal, so MB is also 6. Same picture for all of these midpoints. A and B are the endpoint, M is the midpoint. This time they tell us that MB, the length between those 2 points, is 9, and they want the length of AB. Now, AB includes both halves, so it would be 9 plus 9, and the entire length is 18. Pay really close attention to whether they're asking you for another half or they're asking you for the whole. If they give you a half and ask for the whole, you double it. Number 3, M is the midpoint. We know that the length from A to B, this distance, is 8. And they're looking for how far it is from A to M. The length of AM would be half of that, so 8 divided by 2 is 4. Every time we start problems, though, eventually after we use some numbers, we'll work in some algebra. So this is one of the algebra problems. It tells us that AM, that length or the distance from A to M, is x plus 7. And from M to B, that length or distance is 3x minus 5. Because M is the midpoint, we do know the two halves are equal. So we're going to set x plus 7 equal to 3x minus 5 and solve. I want to pick the smaller x and move it. This is like a 1x, and it's positive, so I'm going to subtract the 1x. Be sure if you do that on the left, you're also doing it on the right. So 7 equals 2x minus 5. All of our x's on the right, so we're going to move our numbers to the left. I'm going to add 5 to get rid of the minus 5. 12 equals 2x. 2 and x are against each other, so it's multiplied. We're going to divide by 2 to get x by itself, and it's 6. This is a case where you will be asked to plug back in. So when you get that x is 6, you are not finished with the problem. They're asking for the length of AM. AM, I know, is my x value plus 7. Since our x value is 6, 6 plus 7 is 13. So the length of AM is 13. If it helps when you get your test on Wednesday, write down, always plug back in, so you're sure that you're plugging back in and getting the correct answer. Number 5 says the length of AM is 5x minus 3. The length of MB, the other half, is 2x plus 12. Again, since these are the two halves, they are equal, so we're going to set 5x minus 3 equal to 2x plus 12. When I'm moving my x's, I would like to move the smaller x value, so I always get a positive answer. I'm going to move the 2x by subtracting it, because it's positive, and we subtract on both sides. So we have 3x minus 3 equals 12. All of my x's are on the left, so I need to move my numbers to the right. To get rid of minus 3, we're going to add 3. So 3x equals 15. And again, those are against each other, they're multiplied, so we divide by 3, and x is 5. We always need to plug back in. I'm going to take my x value of 5 and plug it in for MB, what I'm trying to find. So we're going to do 2 times 5 plus 12. 10 plus 12 is 22. That's the answer I would put on the blank. Again, M is the midpoint between endpoints A and B. This time they tell us that AM is 2x plus 8. And MB, the other half, is 4x plus 6. Again, they're giving me the two halves. I'm going to set those equal. So 2x plus 8 equals 4x plus 6. We're moving the smaller x value, the 2x, by subtracting. So 8 equals 2x plus 6. And we're moving the numbers to the left. It was plus 6, so we subtract. 2 equals 2x. And when you divide by 2, you get that x is 1. We need to plug this back in. However, this time they want AB, the entire length, and I don't know anything about AB. So I'm going to plug into the half. If I do 2 times 1 plus 8, I get 2 plus 8, which is 10. That tells me from A to M is 10. MB should be 10. It should be the same length. We could plug the x value in to double check. 4 times 1 is 4, plus 6 is 10. So the length of the whole thing, AB, is 20. And again, as long as you're comfortable with your x value answer, you could have repeated the 10. Plugging back in for MB just guaranteed that we had the right answer. Number 7, same picture. M is the midpoint. The length from A to M, that distance, is 3x plus 5. This time, from A to B is 7x. This is a different type of problem. If they give you the 2 halves, you're setting them equal. This one gives you a half and the entire length. Anytime they give you a problem like this, you're going to do 2 times the half equals the whole. So we're going to do 2 times the 3x plus 5, because it would take 2 of those to add up to the whole length of AB, 7x. Be sure you distribute first. 2 times 3x is 6x, plus 2 times 5 is 10. The only place I have regular numbers is the 10 on the left, so I'm going to move all my x's to the right by subtracting 6x. So 10 equals 1x. That's just x, so that's my value. X is 10. We need to find the length of AM, so I'm going to go back to AM and plug in that x is 10. 3 times 10 is 30, plus 5 gives me a length for AM of 35. I could plug the 10 back in for AB. It should be twice as long because it's the whole length. 7 times 10 is 70. That is twice as much as 35. That's just a way you can double check and make sure you have the correct answer. Number 8 says that the length of MB is x plus 3. The length of AB, the entire length, is 5x minus 9. Again, this one gives me a half and a whole, so we're going to do 2 times the half MB equals the whole AB. You must distribute first to clear parentheses. 2 times x is 2x. 2 times 3 is 6. Be sure you include your plus between. I'm going to move my smaller x value by subtracting 2x. That will give me that 6 equals 3x minus 9. All my x's are on the right. I'm going to move the numbers to the left, so I'm going to add 9 to both sides. 6 plus 9 is 15. 15 equals 3x. And if we divide by 3, x is 5. Again, I need to plug back in. This one's the length of AB, so I'm going to go back to AB and plug in an x value of 5. 5 times 5 is 25, minus 9 gives us a length for AB of 16. If you'd like to double check your answer, MB should be half of that, so we plug in the 5. 5 plus 3 is 8, that's half of 16, so I know I got my answer correct. Looking at the angles, and we talked about bisectors, and bisectors have to be rays, we're going to set up these problems the same way. So we know that ray OB, and there is an error on the slide, my symbol for ray did not show up, so I'm going to make this a ray. Ray OB bisects angle AOC. Now I'm going to fill in what they tell me. They tell me the measure of angle AOB, AOB is the small angle on the left, is 3x plus 11. And the measure of angle BOC, BOC is the small angle sort of to the right, is 6x minus 10. The first thing I'm going to do is set this up, and don't look at what they're asking you for. Set up the problem first. If they give you each small angle, just like with midpoint, when they give you the small segments, you set them equal. We're going to set these two small angles equal. If they give you a half and a whole, you always do 2 times the half equals the whole and distribute. So they gave me the two small parts. I'm going to take the 3x plus 11, set it equal to 6x minus 10. So 3x plus 11 equals 6x minus 10. When we solve, we're going to move our 3 over, since it's a smaller x, by subtracting, because it's positive. So 11 equals 3x minus 10. We're going to add the 10, because it's a minus 10. It's like having a negative. So those will cancel. And we get that 21 equals 3x. To get the 3 and the x apart, they're multiplied, so we're going to divide. And we have that x is 7. Now we want to go back and plug in. So knowing that x is 7, I'm going to go back to the original slide. We have that x is 7, and we want the measure of AOB. So we're going to plug the 7 in for x and AOB. 3 times 7 is 21, plus 11 is 32. Be sure you're using order of operations and multiplying anything that needs to be multiplied before you add or subtract. The next angle example, again, ray OB, same picture, bisects angle AOC. This time the first angle on the left, AOB, is 5x plus 14. Kind of the angle to the right, BOC, small angle BOC, is 7x minus 10. Again, they gave me the 2 halves, so I'm going to set those equal. I'm going to set the 5x plus 14 equal to the 7x minus 10. 5x plus 14 equals 7x minus 10. I'm going to flip back and make sure I copied those down. 5x plus 14, 7x minus 10. Again, it's easier to get a positive answer if we move our smaller x, so I'm going to subtract the 5x from both sides, and those cancel. So we have 14 equals 2x minus 10. I'm going to move all the numbers to the left because all my x's are on the right. To get rid of minus 10, we add 10. And we have that 24 equals 2x. If we divide both sides by 2, x is 12. So knowing that x is 12, I need to go back to the original problem, plug in, and make sure I answer the question. I have that x is 12, and you always want to show on tests or quizzes that you found that x is 12. You will get half credit for finding that correctly if you forget to plug back in or if you make a mistake when plugging in. So we're going to go back and plug in that x is 12. Now this one does ask me for the measure of angle AOC. AOC is the entire angle. I don't know anything about the entire angle, so I'm going to plug it into either each half and add it up, or plug it into half and double it to get the whole angle. If I plug in that x is 12, 5 times 12 plus 14. 5 times 12 is 60, plus 14 is 74. I'm going to plug into the other half just to make sure it's right. 7 times 12 is 84, minus 10 is 74. So the whole angle AOC is 74 plus 74, or 148 degrees. On problems like this where we're using one picture for multiple problems, be careful not to assume that it will look any certain way. This angle is going to be a symbol. It doesn't look like it's 148 degrees. That's okay. This is the correct answer. This picture is being used for multiple problems, so it may look acute and you may get an obtuse answer, and that's okay. Moving on to the next one, we have that ray OB bisects angle AOC. This one tells us that the measure of angle AOB, so I'm going to trace AOB as the one on the left, and that's 3x plus 5. The measure of angle AOC, and if you trace AOC, that's the entire angle. So I'm going to do the arc that shows the whole angle is 7x. Again, if they give you half and the whole angle, you're going to do 2 times the half and set it equal to the whole. So we're going to take 2 times this half AOB, 3x plus 5, and set it equal to the whole 7x. And I'm going to do this on the next slide. 2 times this quantity, those are the parentheses, 3x plus 5 equals 7x. So anytime you have only half of the figure, one half of the angle or the other, you multiply that by 2. So 2 times 3x is 6x. 2 times 5 is 10 equals 7x. If we subtract the 6x because it's smaller from both sides, we get that x is 10. Again, we need to go back and plug in. So I'm going to take that x is 10, and we're going to go back and we're going to plug in. So x is 10. We want the measure of angle AOC, so 7 times 10 is 70 degrees. Again, these may not be drawn to scale. This is a representation for setting up the problem. We're actually going to stop here. When you come into class tomorrow, we will talk about these constructions, and we'll work through those, and then we'll have a handout.